Okay, so I'm going to go over real quick. This will be like a tutorial video, if I could say it was that, and it'll be on functional groups. And so today we will be covering specifically level 2 functional groups. Now, let's get straight into it. Understanding functional groups. So what is a functional group? A functional group essentially is when there is something or there is a characteristic of a molecule. So there is a characteristic of a molecule that defines or that gives that molecule its chemical and physical properties, because that's what functional means, right? Properties. And so essentially when we're looking at functional groups, we have to understand what functional groups are present within organic molecules so that we know what types of physical and chemical properties that compound may have. Okay, and so there's many different types of functional groups that we can go through. This is just a level 2, and it's really important that we know how to recognize these functional groups, because it's an important part in the first step of understanding organic chemistry, which is essentially naming organic compounds. So let's just start off right off the bat with alkane. Okay, and so alkane molecules essentially are a situation where you have, let's go R and C, single bond C and R. Okay, so this idea over here, in which there is only a single bond between carbons, this is when what we would recognize as an alkane, sorry. Okay, not an alkene. Okay, and so some common alkanes that you should know is octane. So octane is a common example, right? And that's your petrol. Okay, and we also know that there is also examples such as methane gas. Okay, and so essentially that's exactly what an alkane is. An alkane is the situation where we have only single bonds that exist, single bonds that exist between carbon molecule or carbon atoms. Right. Let's move on to the next one, which is alkene. And alkene is the situation where you see that there is two lines, or in other words, there's a double bond. So this is recognized as a alkene. And an alkene, of course, suggests that there is a double bond somewhere within the molecule. Oh, my tablet is freaking out. Double bond between a, well, not a, but two carbons. Okay, and so we can have methane as an example, or another one is propene. Okay, and so that's important as well. So whenever you see this double bond structure over here, that's when you know there is an alkene present. Okay, Let's move on to the next one, alkyne. So alkynes are very similar to alkenes and alkenes, in that they suggest that there is a triple bond somewhere in the molecule, or between two carbon atoms. Okay. And then, of course, examples include ethine or ethylene, sorry, not ethylene. We can go propine. That's what I was supposed to say. Propine, etc. Okay. Now, haloalkane. The functional group of an haloalkane. We don't usually consider it a functional group, but I'll say that it is in this case. Okay. But a functional group such as an haloalkane suggests that we have a carbon that is bonded to some sort of molecule X, where X is a halogen. So remember, your halogen are your group 17 elements. Okay, so they consist of bromine, chlorine, iodine, and fluorine. Okay, so a common example would be something that looks like this. C that's bonded to a Br. Just recognize that this R over here means rest of the chain. So it just means whatever's there. Okay, it's not really that important, so we just denote it as R of the chain. Okay. It can also be C, Cl, it could be sorry, that's a C, Cf. So anytime we see a haloalkane, a halogen, it's classified as a haloalkane. Okay. Now carboxylic acid. Carboxylic acid is a really interesting one, and it becomes even more interesting in level 3. But when we look at if we look at this carboxylic acid, it's this entire group over here. This is known as the carboxylic acid group. Carboxylic acid group. Okay. And so that's when you have a carbon singly bonded to an OH and doubly bonded to a oxygen atom. Okay. And so common examples of carboxylic acids are ethanoic acid. So when you're thinking about ethanoic acid, it's commonly referred to as vinegar. So that's ethanoic acid, aka vinegar. Okay, that's a common example. Now, alcohols. When we're looking at alcohols have been denoted as something that is attached to an OH group, not to be confused with a carboxylic acid. So recognize that a carboxylic acid has both the double bond O and the OH connected to the carbon over here, whereas a alcohol only has the OH attached to it. And so this is a OH, or we call this a hydroxyl group, or an alcohol group. Singly bonded to a carbon. Okay, and so I'm sure everyone is aware of alcohols. We have ethanol, propanol, okay, methanol, okay, oh, that's an L, okay. And then the last one, the last functional group that we can have is this idea of an NH2 group. So we call this group over here an amine group. Okay, and these amine groups are slightly basic. Okay, slightly basic. And yeah, so essentially this covers all the functional groups that you need to know. Okay, remember that overall, I went through very fast, but the reason why you need to understand it is because functional groups determine properties, sorry, of organic compounds. Okay, and so this relates heavily into two things: nomenclature, which is the naming conventions. Okay, and then of course reactivity. Okay. For example, carboxylic acids are of course acidic, right? So you would expect them to do things, for example, things that alkanes cannot do, right? And so it's really important to understand these types of subjects. So I hope that this helped. I know it was really fast, but yeah. Um hopefully you can watch this and supplement this with best choice videos, and I hope that helps. So I'll see you in the next video.